Hi class, and welcome to our lesson on 11.2. In this lesson we're talking about geometric sequences. So in 11.1 was arithmetic sequences, I told you to think add. To get from one term to the next you have to add. So for geometric there's going to be a lot of similarities, except this time to get from one term to the next we're going to multiply. So that's the definition of a geometric sequence. It's a sequence in which each term after the first is found by multiplying the previous term by a certain number, that number being a constant. That number in arithmetic was called the common difference. In geometric it's called the common ratio. It's the ratio of successive terms in a geometric sequence. So it's the number that you multiply by to get to the next term in layman's terms. So here we have 2, negative 6, positive 18, negative 54. You notice how it's alternating positive to negative, so on and so forth. So that means that you're multiplying by a negative number, and to get from 2 to 6 to 18 to 54, you're multiplying by 3. So to get from one term to the next, you multiply by a negative 3. So your common ratio, so a lot of times we just say R, the ratio is a negative 3 for this sequence. Okay? So we're looking at this one. How do we find the next term in this sequence? How do we get from this term to this term to this term to this term? Might be a little bit harder to see to going from here to here and from here to here. But how do you get from 36 to 12? Don't you divide by 3? All of these, if you take 324, divide by 3, you get 108. Divide by 3, you get 36, so on and so forth. So to get our next term, we're going to end up dividing by 3. So 12 divided by 3 is 4. There's our next term. Now I want you to be careful. Our common ratio is not 3. Our common ratio is a number that you multiply by. So we divide by 3. So when we divide by 3, that's the same thing as multiplying by the reciprocal, so we're multiplying by 1/3. Our common ratio in this one is 1/3. You can do that in your calculator too. Multiply 124 by 1/3, 108 by 1/3, times 36 by 1/3. 12 times 1/3 is 4. So get that into your head. Your common ratio is always the number that you multiply by. Don't think divide, think multiply. Number 2, find the next term in this sequence. Well, how do we get from here to here? You have to multiply by a negative 5. So times a negative 5, multiply by a negative 5 to get to negative 75. And so what's 375 multiplied by a negative 5? Negative 1875. Multiplying each term by a negative 5. So we're going to have two formulas again, just like we had for arithmetic. We have our explicit formula, and you should know what each and every one of these variables mean now, except we haven't dealt with R yet. Instead of the common difference in arithmetic, our common ratio is going to be that letter R. So the number that you multiply is this letter right here. Otherwise, you know all the other terms from our previous lesson, and here's our recursive formula as well. So we're going to be using both of these on our video lesson for today. Write out the first 5 terms of this geometric sequence, for which a negative 3 is the first term and the common ratio is a negative 2. So our very first term is a negative 3. And then we find each and every term by multiplying by the common ratio, which is a negative 2. So if you multiply by a negative 2, you'd get a positive 6. Multiply by a negative 2, negative 12, positive 24, negative 48. So hopefully that makes sense. To get from one term to the next, all you simply do is multiply by a negative 2. Okay, now we're getting into, again, more of the practical application type questions. To find the 20th term, I don't want to keep on multiplying and multiplying and multiplying and multiplying. If I had a formula, that would be much more efficient. And here's our formula that we're going to use. Write an explicit formula. So what we're going to do here is our sequence is 5, 10, 20, 40. So what's our common ratio? What is the number that we're multiplying by? Hopefully you see that rather quickly. We're multiplying by 2 every time, are we not? So our ratio is 2. So we don't know the value of my last term because we haven't even talked about a last term yet. So what is a sub n when the value of my first term is 5? It's this one right here. Multiplied by the common ratio, which is 2, raised to the number of terms that we have. In this one, when we write the explicit formula, we don't know how many terms we have. So here is our answer for 4a, because this gets us the value of our last term as long as we know how many terms there are. So now for letter B, we're going to use this formula to find the value of the 20th term. what is a sub 20 when I multiply 5 by 2 20 times? What value is that going to give us? Well, it's 5 times the common ratio of 2 raised to the 20 minus 1. So now you can do the rest in your calculator. It's 5 times 2 raised to the 19th. Make sure you do order of operations though, so make sure you do the exponents first. It's 2 raised to the 19th power, get that value, and then multiply it by 5. And that's the value of your 20th term. Why don't you try that in your calculator? When you do that, you should get 2,621,440. So there is the value of your 20th term. Okay, let's try the next one. This one is going to be using the recursive formula instead of the explicit formula. So for our recursive formula, all it means here, class, is that this is the value of the previous term. So to find the value of the term that you want, you just got to multiply the previous term by the common ratio. If I want to know what number this is, I got to multiply this by the common ratio. So multiply the previous number by the common ratio. That's all that that's saying. Okay, now that we know that, let's fill in letter A here. We know that the value of a sub 1 is 2048. And now, when we want to find a sub n, we got to take the ratio times the value of the previous term. So I ask you this question, class. What is this ratio? How do you get from here to here to here to here? It's kind of like saying 2048 multiplied by what number gives you a negative 512? What do you have to multiply 2048 by to get a negative 512? Well, we can simply divide by 2048, and then we would get x. So a negative 512 divided by 2048. When you do that, our common ratio, the number that we multiply, is going to be a negative 1/4. A negative 1/4 is our common ratio. So that's going to go right in here. And you could try this for every one of them. You're going to multiply by a negative 1/4, multiply by a negative 1/4, multiply by a negative 1/4. You could continue in getting each and every one of those terms. So our common ratio, negative 1/4, multiplied by a sub n minus 1, which is just the value of the previous term. So there's our answer for letter A. And now we can use this to find the value of the 7th term. We got to do this in order though, because we can't find the 7th until we know the 6th, and we can't find the 6th until we know the 5th. So what do I know? I know the value of the 1st, I know the value of the 2nd, I know the value of the 3rd, and I know the value of the 4th. Whoopsie. And the value of the 4th. So I'm going to start off by saying, what's the value of my 5th term? What's a sub 5? Well, if this right here is a sub 5, then that equals a negative 1/4 multiplied by a sub n minus 1. And if n is 5, what is 5 minus 1? Simply a sub 4. So I got to take, to find a sub 5, a negative 1/4 multiplied by the value of my previous term, which is the value of my 4th term, right here, a negative 32. So you guys can do that in your calculator. What happens when you take a negative 1/4 multiplied by a negative 32? You get the answer 8. A sub 5 equals 8. All right, we got to find a sub 7, so let's keep on going now. Our next step is to find the value of our 6th term. A sub 6 equals a negative 1/4. If this now is a sub 6, then that means I have to multiply a negative 1/4 times a sub 6 minus 1, which is a sub 5. So a negative 1/4 times the value of my 5th term, which is a positive 8. So what is the value of my 6th term? A negative 1/4 times 8 is a negative 2. There's the value of my 6th term. So now finally I can get what I want. I want the value of my 7th term. So the value of my 7th term is a negative 1/4 times the value of my 6th term, which is a negative 2. So what's a negative 4 times a negative 2? That is a positive 1/2. And there's your answer. The value of our 7th term is 1/2. It's kind of cumbersome, but it is a beneficial thing to show your work on how we can get each successive term by multiplying by the common ratio. A sub 7 equals 1/2. Okay, number 6, throwing a little wrinkle into things here. Find the seventh term of a geometric sequence for which the third term is 96 and the common ratio is 2. All right, your end goal, you want to find the value of the seventh term. You want to find a sub 7. But what's too bad is you don't know the value of your first term. You know the common ratio is 2, and then n minus 1 is the number of terms, so that would be 7 minus 1. I can't do this, though, until I first find the value of a sub 1. I know a sub 3, but I do not know a sub 1. So here's what I can do. If I know that a sub 3 is 96, let's call that a sub n right now. The value of my last term, or the value of my third term, is 96. I'm going to find a sub 1 now, because I know my common ratio is 2 raised to the n minus 1, which if n is 3, 3 minus 1. The value of my third term is 96, so there's 3 terms in this equation that I'm doing to find a sub 1. All right, let's solve for a sub 1. 96 equals a sub n times 2. This is the same thing as squared. 3 minus 1 is 2, so 2 squared is 4. Divide both sides by 4. What's 96 divided by 4? The value of a sub 1, 96 divided by 4, is 24. Aha! Now, my friends, I can solve for the value of the seventh term. A sub 7 equals the value of my first term, which I found. It is 24 multiplied by 2 raised to the 7 minus 1. So it's a sub 7 equals 24 times 2 raised to the 6th. You can do that in your calculator. Once again, do exponents first. So do 2 raised to the 6th power, and then multiply that by 24. When you get that, you should get 1,536. And there's your answer for that one. All right, let's try one more. How many terms are in this sequence? So we know the first term is 3, the second term is 6, the third term is 12. We can now find our common ratio. What is our common ratio? How do you get from one term to the next? Quite simply, you just multiply by 2, right? So how many terms? In our equation, the value of my last term, a sub n, equals a sub 1 multiplied by the common ratio raised to the n minus 1. So if I want to find how many terms there are in this sequence, I want to find n. N tells me how many terms there are. I know the value of my last term. It's 98,304. 98,304 goes on the left side of the equation. A sub 1, the value of my first term, is 3. Multiplied by my common ratio, we established that it is the number 2 raised to the n minus 1. Woo! Now, we are going to solve for the letter n. First, we're going to divide both sides by 3. Because then we'll get 2 raised to the n minus 1 all by itself. We're going to take 98,304 divided by 3. When you do that in your calculator, you're going to get 32,768. That equals 2 raised to the n minus 1. All right, now to solve for n, there's a couple different ways that you can do this. What I might recommend is this has a base of 2. See if you can get this to be a base of 2. So 32,768, is that a power of 2? Can you raise 2 to a number and get 32,768? Why don't you guys pause the video and try that a few times. After you've tried, hopefully you got 2 raised to the 15th power is that number we were looking for, 32,768. So I can change this into 2 raised to the 15th. That equals 2 raised to the n minus 1. Now that I have common bases, base 2 and base 2, I can set their exponents equal to each other. So 15 equals n minus 1. Add 1 to both sides. There we have it. N equals 16. This value right here, 98,304, is the 16th term in this sequence. We'd get 3, 6, 12, 24, 48, 96. Keep on going, keep on going, keep on going. The 16th term is going to be this one right here. So that's how you do problem number 7. Let me know if you have any questions on that when you get to class tomorrow.